Welcome to today's video on Unit 11, Chapter 2, the Notes Part 2. Now we're going to start talking about derivative rules. So last time we talked about the derivative and how it is the slope. And you learned that you had to take the limit, so it could be a little tedious and messy, and we had a lot of steps. And believe it or not, as it says here, you've been asked to find derivative of simple functions. Just imagine how difficult finding the derivative becomes when the function is more complicated. But we have rules for that. And so we'll talk about the different rules here. The first rule is the constant rule. When you find the derivative of a constant, it is equal to 0. In other words, this says the derivative of a constant is 0. Why does this make sense? Because the slope of any horizontal line is equal to 0, right? And y equals 5 is a horizontal line, so the derivative should be 0. So if you find in here y prime equals 0, f of x equals -3, f prime of x equals 0, p of r equals 4, p prime of r equals 0, and then here g of t equals k e to the third pi. Notice the variable is t, so this is a constant, so g prime of t is equal to 0. So the proof of the constant rule, so if we let f of x equal c, and we find the limit as the change in x approaches 0, well, f of delta x plus x is still c, so it's basically c minus c over delta x, which is the limit as delta x approaches 0 of 0 over delta x, which is just equal to the limit as delta x approaches 0 of 0, which is just 0. So that gives you the proof of the constant rule. All right, so the next rule is the power rule. And the power rule, you maybe already noticed it from previous work, but if you took the derivative of f of x equals x to the third, you would get 3x squared. Or if you found the derivative of x to the seventh, you got 7x to the sixth, and so on. So there is a pattern, and the pattern is if you take the derivative of x to the nth, that it is n times x to the n minus 1. All right, so in words, you're going to make the power a coefficient and reduce the exponent by 1. So that is the power rule. That is the power rule. So if you had these questions like y equals x to the 15th and you want to find the derivative, well, it becomes 15x to the 14th because you make this the coefficient and then you subtract 1. So now if you're talking about the fourth root of x, we want to first make it a fractional exponent, so it's x to the 1/4, and then when we take the derivative, we get 1/4 x to the -3/4, because 1/4 minus 1 is -3/4. So we could write this as 1 over 4x to the 3/4. You don't have to put it back as a radical. No need to do that. All right, so p of r equals 1 over r to the 5th. So that's the same as saying r to the -5th. So when you take the derivative, you get -5r to the -6th, which is the same as -5 over r to the 6th. And then the last one here, we'll make this t to the negative 2/3 power. So that becomes, when you take the derivative, negative 2/3 t to the negative 5/3, which simplifies to negative 2 over 3 times t to the 5/3. So if f of x equals x, what does f prime of x equal? Well, the answer is 1, because f prime of x equals, well, basically it would be x to the 0, right? It'd be 1x to 0, which is just 1. So if we look at the proof of the power rule, f of x equals x to the n. So that means the derivative is equal to the limit as delta x approaches 0 of x plus delta x to the nth minus x to the nth all over delta x. And if we continue that and expand it out, we would have, well, x plus delta x to the nth. That means, remember binomial theorem, n choose 0, x to the nth, plus n choose 1, x to the n minus 1, plus, or sorry, n choose 1, and then delta x, plus n choose 2, x to the n minus 2, delta x squared, plus dot dot dot, and then it would be n choose n, and then it'd be just delta x to the n minus, sorry, it'd be delta x to the nth, and then minus the x to the nth, because all over delta x. Well, when you factor out the delta x's, right? When you factor out the delta x's, you get the limit as delta x approaches 0 of n choose 1, x to the n minus 1, plus n choose 2, x to the n minus 2, delta x, plus, and then you can continue dot dot dot, n choose n of delta x to the n minus 1. And remember, here, this and the x to the nth will cancel out, so that's where we are. And then when you put the 0 in for the delta x's, all the terms with the delta x go away. So you're just left with n choose 1, x to the n minus 1, which is the same as saying n times x to the n minus 1. Constant times the derivative. All right, so whenever we're multiplying a constant times a function, the derivative is just the constant times the derivative. So there's some examples there, but let's do some on the next page. So y equals 5x to the 5 over 3x to the 4th. That's the same as 5/3 times x to the negative 4th. Then when you take the derivative, that's the same as taking the derivative with respect to y of 5/3 x to the negative fourth. So that means you're going to take 5/3 and multiply it times the derivative of x to the negative fourth. So that's equal to 5/3 times negative 4 times x to the negative fifth. Well, 5/3 times negative 4 gives you negative 20 over 3x to the fifth. So that is your derivative. So the next one, s of t, well, we can rewrite this as negative 4/3 times t to the negative 3/5. So it's going to be the derivative of negative 4/3 times t to the negative 3/5. So it's equal to negative 4/3 times the derivative with respect to t of t to the negative 3/5. And that is negative 4/3 times negative 3/5 times t to the negative 8/5 when you subtract 1. So notice the 3's here cancel. So you have 4/5. Actually, you have 4 over 5t to the 8/5 is your final answer. All right, so I'll give you a chance to do some of these on your own, and then actually I'll give you a chance to do B since that's one we haven't done, and then I'll post the answer. All right, so if you look, here's the answer to part B. First change it from a radical to a fractional exponent, and then you can subtract 1 and multiply by 2/5. So you get 14 over 5t to the 3/5 power. All right, proving the constant multiple rule. So if we take the limit as delta x approaches 0 of the constant times f, the constant times f of delta x plus x minus the constant times f of x all over delta x. So if we simplify this, notice we can take out the constant here. So we get that times f of delta x plus x minus f of x all over delta x. So that means that it's the constant times the limit as delta x approaches 0 of f of delta x plus x minus f of x all over delta x. And notice this here is the derivative, so it's equal to the constant times the derivative of f of x. So that's how you prove it. All right, sum and difference rules. Sum and difference rules basically means if you're adding or subtracting two functions, then it's just the derivative of one function plus or minus the derivative of the other function. So it's the sum or difference of the derivatives. So there's some examples here, and we'll do that. So first of all here, if it's multiplication but you can distribute, I would do that. So I'd make it x to the fifth minus 2x squared, which means it's the derivative of x to the fifth minus 2x squared. So it's the derivative of x to the fifth minus the derivative of 2x squared. So then it's the derivative of x to the fifth minus 2 times the derivative of x squared. So it would be 5x to the fourth minus 4x. So that is the derivative. And here I just did it so I skipped a step, which is fine. So there you go. So the next one, here you have 1/2 r to the negative 1/2 minus pi k. So you have the derivative of 1/2 r to the negative 1/2 minus pi k. Well, when you take each derivative separately, you get 1/2 times negative 1/2 r to the negative 3/2 minus, and pi k is a constant, so 0. So it's equal to negative 1/4 r to the negative 3/2, which simplifies to negative 1/4 r to the 3/2. So that is your derivative. So go ahead, and we've already done this one, so go ahead and try B on your own, and then I'll post the answer. All right, so there's the answer. Hopefully makes sense, because the derivative of t is just 0 because t is a constant. So the proof of the sum and difference rules, I'll do the sum, and the difference rule is pretty much the same. If you're looking for the derivative with respect to x of f of x plus g of x, well, that means it's the limit as the change in x approaches 0 of f of delta x plus g of delta x plus x minus, and then f of x plus g of x all over delta x. So then that's the same as the limit as the change in x approaches 0 of, and now we can distribute the negative sign here. So we get f of delta x plus g of delta x plus x minus f of x minus g of x all over delta x. So then if we group the f's together, and the g's, so we have the limit as x approaches 0 of f of x, f of delta x plus x minus f of x all over delta x, plus the limit as x approaches 0 of g of delta x plus x minus g of x all over delta x. And notice that just means that we have f prime of x plus g prime of x. All right, so there is your proof. All right, so next we're talking about trig derivatives, sine and cosine rules. So the derivative of the sine is the cosine, and the derivative of the cosine is negative sine. So if you graph this, first I'll graph the sine function and make this pi and 2 pi. 1 and negative 1. So notice here's the graph of the sine function. And notice it goes on forever. There. All right, so now if you talk about the slope of the sine function, well, the slope here, notice it's rising, right? It's a line. So the slope here at 0 is 1. Then when you get to here, it's a changing point, and remember, what's the slope of a changing point? It's 0. And then the slope here, notice it's going down. It's a line, so it's -1. And then here it's a changing point, so the slope is 0. And then here it's going up again, so the slope is 1. So notice here's the graph of the derivative. And notice this graph is the cosine graph. So that's why the graph of the sine, the derivative of the sine, which means the graph of the slope, is the cosine. Likewise, if we drew a graph of the cosine function, so remember this is the cosine function. So remember this is actually a turning point, so the slope would be 0 to start with here. Then notice it's going down, so the slope's -1. Turning point, slope is 0. Up, so it's +1. And then it's a turning point here, so 0. So notice the graph of the derivative is the opposite of the sine, because the sine would go up and then down. So that's how those derivatives get to be. All right, so finding the derivative using these rules. So remember, this is the same as saying y equals 3/2 sine x plus 2 cosine x plus 4/3 x squared. So when you take the derivative with respect to x, it's going to be 3/2 sine x plus 2 cosine x plus 4/3 x squared. So remember, that means we can take the derivative separately of all of these functions. Two cosine x plus the derivative with respect to x of 4/3 x squared. Now remember, the constants can be pulled out, so it's 3/2 times the derivative with respect to x of the sine plus 2 times the derivative with respect to x of the cosine plus 4/3 times the derivative with respect to x of x squared. So the derivative is 3/2 times cosine x, because remember the derivative of sine is cosine, plus 2 times negative sine x, plus 4/3 times 2x. So then you just simplify, and you get 3/2 cosine x minus 2 sine x, and then plus 8x over 3. So that is your final answer. All right, try the next one on your own, and then I'll post the answer. All right, so there's the answer for this one. Take each derivative separately, and then remember -3/5 times 4 is +12/5. And then you just make the exponent positive. All right, that concludes the first part of the notes. I'll continue with the next video talking about proving the sine rule and also some word problems with velocity and acceleration. All right, so continue with the next video. Have a good rest of your day.